All right, the fact that we take these in 15-minute intervals allows me to write some stuff. The homework from 11.2 and 11.1, 11.2 hard copy will be emailed to you with the answers and also my notes for this lecture. Those of you who still want to do WebAssign, you can do WebAssign 11.1, 11.2. You could also do WebAssign for the rest of the year, but following 11.2, I get into what I call a hard copy worksheet, and each one counts as a small take-home test. So I will grade it if you do the WebAssign, but I'm also grading the small. It's a series of take-home tests. It makes it a lot easier to teach the rest of the course. Okay, so let's take some more examples. Don't forget, we're talking about natural logs. Here we have our argument is now a polynomial of higher order. So in order to take dy dx, we're going to let u equal x fourth minus 3x plus 7. And notice, for all these things, we just need u and du dx. This is 4x third. This is minus 3, and of course that's 0. So now our rule says 1 over u du dx. So it's 1 over the whole thing now. X fourth plus 3x plus 7 times 4x third minus 3. So this is going to be equal to 4x third minus 3 over x fourth plus 3x plus 7. Now it is definitely, you actually can factor this, but you do not know how, and I'm not going to teach it to you. That would have been in a pre-calculus class, but I don't think they teach that anymore. So basically this is your answer, and it's perfectly acceptable. So let's take another example. Now everybody take a minute and see, what do we have here? We no longer have just one function. X squared is a function of x, and log of x is a function of x. So here we have what we would call a function u times a function v. It's multiplied together. So if I want to take the derivative, I'm going to use the product rule. Can't escape those, right? That would be u times the derivative of v plus v times the derivative of u. So let's do that. Well, u is simply x squared. I want to take the derivative of log of x plus v is the log of x. And I want to take the derivative of x squared. Well, if you remember from before, the derivative of the natural log of x was just, so from before, which is one of the other problems, we found that the derivative of the natural log of x was simply 1 over x. So we can put that in here. That's going to be x squared times 1 over x plus the natural log of x times 2x. Bring that up here, it's x to the minus 1. You're going to get x plus 2x natural log of x. And that's it. Notice this one, because of the multiplication, the log still remains. So our derivative is still a log function, which is okay. So x plus 2x log of x. So let's go on and do some more. And I think I might do one that's a little bit more difficult. Let's do a quotient rule. Everybody loves the quotient rule. As a rule, if you can turn a quotient into a product, that makes your job a heck of a lot easier. Sometimes you can't. So let's see what we have now. We have y, another example, y equals the log, natural log, 2x plus 1 over 2x plus 1. Well, I could take the 2x plus 1 to the 1 and bring it up to the side and make it a minus 1. It would make my job a little bit easier, but this is designed to use the quotient rule. So for the quotient rule, I'm going to make this be u over v. So u is going to be my log to the 2x plus 1, and v is going to be simply the binomial 2x plus 1. So what's the quotient rule? Well, I take the bottom times the derivative of the top, and I subtract it. Notice I put a bracket. Top times the derivative of the bottom. I always put a bracket when I'm distributing a negative sign, and I square whatever in the bottom. So let's substitute in and see what we get. Well, we know v is 2x plus 1. I want to take the derivative of the log I'm going to be subtracting that from u, which is log of 2x plus 1 times the derivative of 2x plus 1. Now, don't forget, when people take the quotient rule, a lot of time they forget to divide. Really messes up their answer. I'm going to take 2x plus 1, and it says to square it. So this gives me the quotient rule. Notice, let's write this a little bit better. Notice I can, let's look at this part here. That's the only thing that we have to take a log in. I'm going to call this A. I'm going to call this equation 1. And I'm going to look at A all alone. The derivative of the log of 2x plus 1. I'm going to get u equal 2x plus 1. So the du dx is simply 2. So I know that the derivative of this is going to be 1 over u, or 1 over 2x plus 1, times du dx, which is 2, or 2 over 2x plus 1. Now I'm going to substitute this back. Substitute in A in equation 1. That's this. So y prime of x is going to be 2x plus 1 times 2 over 2x plus 1. Isn't that convenient? Minus the log of 2x plus 1. And the derivative of this is simply 2 plus 0, so it's 2. And I'm going to divide it like this, 2x plus 1 squared. Now notice what happens to this 2x plus 1. They cancel. Isn't that nice? So I get 2 minus 2 log of 2x plus 1 divided by 2x plus 1 squared. And that's about it. I can't do anything with that. It's nice when you get things to cancel. If I couldn't cancel, I could have factored out the 2x plus 1. How much time? Okay, we have 4 minutes to go. So I'm going to have you try this one. Obviously, instead of YouTube, this is you try. And it says find derivative. And we're going to have y equals 1/2 the natural log of 2x to the 6th minus 2x. All right, you try that until our next class. And I'm not going to give you quizzes yet. I will start the second week. But if you do want to hand this in for extra credit, you can. By handing it in means to copy it and email it to me. Now we want to start some practical examples, and I'm really not going to have any time to finish this, but I'm just going to start it. And basically, I'm looking at marginal cost. So what am I given? Given C of x equals 1,500 plus 200 times the log of 2x plus 1. Okay, so we want to find is C prime x, and then there's only one other thing, and then we are finished for today. And then find C prime at 100. And then I'm going to ask another question, which I'll give to you next time. Okay, I'll see you on Monday. Don't forget to do your homework and Chapter 10. I will send you the homework for 11.1, 11.2, and WebAssign should have the homework on as of tomorrow. Have a good weekend and stay healthy.